Welcome to our video on the equation of a straight line. Today, we'll explore the different forms of line equations, work through examples, and talk about parallel and perpendicular lines. Let's start by understanding what a straight line actually is. A line is a set of points extending infinitely in both directions, with no curves or bends. On a coordinate system, we can represent lines using equations that specify exactly which points belong to the line. The most common form of a line equation is the slope-intercept form. It's written as y equals mx plus b, where m is the slope and b is the y-intercept. The slope measures the steepness of the line, how much y changes for each unit increase in x. The y-intercept is where the line crosses the y-axis. Let's visualize what this means. Here's a line with equation y equals 2x plus 1. The slope is 2, which means the line rises 2 units for every 1 unit increase in x. And the y-intercept is 1, so the line crosses the y-axis at the point 0, 1. Another important form is the point-slope form. It's written as y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is a point on the line. This form is especially useful when you know a point on the line and its slope. The third common form is the standard form or general form. It's written as ax plus b y plus c equals 0, where a, b, and c are constants, and a and b are not both 0. This form is often used in more advanced mathematics and when dealing with systems of equations. Let's see how to convert between these forms. Suppose we have a line in standard form, 2x minus 3, y plus 6 equals 0. To convert to slope-intercept form, we solve for y. First, subtract 6 and subtract 2x from both sides. This gives us negative 3, y equals negative 2x minus 6. Dividing everything by negative 3, we get y equals 2/3 x plus 2. So the slope is 2/3, and the y-intercept is 2. Now, let's work through an example. Find the equation of a line passing through the points negative 2, 4, and 1, negative 2. First, we need to find the slope using the formula m equals y2 minus y1 divided by x2 minus x1. Substituting our points, we get m equals negative 2 minus 4 divided by 1 minus negative 2. This gives us negative 6 divided by 3, which equals negative 2. Now we can use the point-slope form with one of our points. Let's use the point negative 2, 4. Substituting our values, we get y minus 4 equals negative 2 times x minus negative 2. Simplifying, we get y minus 4 equals negative 2x minus 4. Adding 4 to both sides, our final equation is y equals negative 2x. Let's talk about parallel and perpendicular lines. Two lines are parallel if they have the same slope but different y-intercepts. Two lines are perpendicular if the product of their slopes equals negative 1. In other words, if their slopes are negative reciprocals of each other. Let's look at an example. Find the equation of a line passing through the point 3, negative 1 that is perpendicular to the line y equals 2x minus 4. First, we identify that the original line has a slope of 2. Since we need a perpendicular line, its slope must be the negative reciprocal of 2, which is negative 1/2. Using the point-slope form with the point 3, negative 1, and slope negative 1/2, we get y minus negative 1 equals negative 1/2 times x minus 3. Simplifying, we get y plus 1 equals negative 1/2 x plus 3/2. So our final answer is y equals negative 1/2 x plus 1/2. Let's visualize our perpendicular lines example. Here's the original line, y equals 2x minus 4 in blue, and our perpendicular line, y equals negative 1/2 x plus 1/2 in red. Notice that they intersect at a right angle, confirming they are indeed perpendicular. In this video, we've covered the three main forms of line equations, slope-intercept, point-slope, and standard form. How to convert between these forms, finding the equation of a line given 2 points, and how to work with parallel and perpendicular lines.